Okay, student, we are going to start chapter named Motion for your first PT examination. In Motion chapter, we will be discussing the following topics. First, we will be giving the introduction of motion. Next, we are going to deal with what is rest. By giving the example, I will be defining both of them. After that, we will be discussing what is types of motion, and after that what is scalar quantity, followed by vector quantity. So this is my first lecture on this chapter. So let's start the chapter. Let's say what is motion, but before giving a definition, we'll dealing with one example. Let's say this is a tree. Just take the example, and here is a car. Simple example I'm giving you. In this car, there is a driver on the front seat, and let's say you are sitting over here, and this is your tree. If I say let's take the time 5 o'clock, what you will see? Both of them are just at rest, or they are just stop. So generally what we see, rest means stop, but in science we'll be dealing what is rest and what is motion in different sense. Let's take after 5:15, what you will observe? This car will reach a certain place, and you and your driver are just sitting wherever you were. So what we find from this example? This car has changed its position, and we have taken tree as a reference point. In short, what we can say, when an object change its position continuously with respect to a stationary object, which can be taken as a reference point, then it will be said as a motion. Here, driver is over here, you are here, you are not changing your position. It means that you are at rest with respect to driver, and you are in motion with respect to tree. So what is motion? Let's define it. A body is said to be in motion when it changes its position continuously with respect to a stationary object taken as a reference point. So according to this definition, you can say this driver and you are in rest with respect to each other, and driver and you are in motion with respect to tree. For example, you are sitting on a chair. You are stationary with respect to the wall, but you are in motion with respect to the earth. Many examples can be taken. So hence we can say that rest Just reverse the definition. A body is said to be in rest when it just does not change its position continuously with respect to a stationary object taken as a reference point. So let's discuss my second topic, that is types of motion. Motion can be classified in different types. For example, just take first type, what we are going to classify on the basis of dimension. First example, one dimensional. Motion. Example, man moving in one direction only. Just a single axis. Can we say along a single axis? Next point, you can take two-dimensional motion. For example, let's take an axis. This is y-axis, this is x-axis, and you are moving like this, like this, like this, like this. This is your motion. In this, you are moving in both the dimension. This is your, we can say, two-dimensional motion. Third is three-dimensional motion. For example, this is x-axis, this is y-axis, this is z-axis. A child is sitting over this stationary point. We can take as a origin, and he is flying a kite. This can be taken as a three-dimensional motion. So I hope you are familiar with this motion chapter. Definition, this is your definition. This is rest definition. We are going on classification of types of motion. So first, I just gave an example of one-dimensional motion, two-dimensional motion, three-dimensional motion. Let's see next type of classification. That is, first one is, let's say B. First one is rectilinear motion. No need of a definition, but you understand the concept. For example, a man moving in a straight path. He just travel straight. You can say one-dimensional motion, yes, is work. So rectilinear motion is what? Motion in straight line or path. Second classification, can you say circular motion? We'll be dealing with circular motion in detail in the last topic. An object is covering a circular path, either clockwise or anti-clockwise. He just rotating. So can we say, in short, motion in circular path. Third one is oscillatory motion. You can take an example of pendulum. This is a pendulum. This is thread, this is bob, and it is just oscillating. It is just oscillating. This type of motion is called two and and fro motion. In this point is extreme, means highest position, and this is initial, we can say it is a mean position. Let's hope it is clear about this type of classification. Now the important one, this is very very important for your examination point of view. I have classified it uniform motion, and my second classification will be non-uniform motion. So what is uniform motion? If we can say, for a uniform motion, if an object cover equal path in equal interval of time, that will be said to be a uniform motion. Next, for non-uniform motion, if an object cover unequal distance in equal interval of time and vice versa. For example, if you see the graph like this, it is your, let's say, distance or position. Over here this is time. This graph is particularly called distance time graph. What we call distance time graph. Let's see for this one also. This is your distance, this is distance, and this is time. If object cover equal distance in equal interval of time, and if we plot them, their position and time respectively, we will be getting a straight line. And for non-uniform motion, we will be getting a curved path, or you can say what we call parabolic. So this is an example of uniform motion, and this is example of non-uniform motion. So remember this graph and even remember the definition. A body has a uniform motion if it travel equal distance in equal interval of time, no matter how small these time interval may be. So non-uniform, just reverse the definition. A body has non-uniform motion if it travel an equal distance in equal interval of time. Let's take an example of these two. You are covering a certain distance, 2-minute time interval. In first time 2 minutes you cover 40 minutes, next you cover 40, means equal distance is there in equal interval time. In this 2-minute time interval, first you cover 40, 60, 20, 80, means on equal time. So on equal distance in equal interval of time. Now for this first lecture, last two topic, that is scalar quantity, and next one is vector quantity. So we will be giving these two definitions in my next class, and in next lecture